What would actually happen if you tried to land on a neutron star? Not orbiting safely from far away, I mean actually going there. The truth is, you wouldn't just die. Your spacecraft would be ripped apart by gravity, your body stretched into a stream of atoms, and what's left of you would slam into the surface at nearly the speed of light. The nearest known neutron star to Earth is located about 400 light-years away. Even traveling at the speed of light, the fastest speed possible in the universe, it would take 400 years to get there. Entire civilizations could rise and fall during that journey. So, reaching a neutron star is already far beyond anything our technology can do. But the journey isn't the dangerous part. The danger begins when you get close. A neutron star forms when a massive star dies in a supernova explosion. During the collapse, gravity becomes so intense that protons and electrons are crushed together, forming neutrons. What remains is the collapsed core of a dead star. A neutron star contains more mass than our Sun, but squeezed into a sphere only about 20 kilometers wide. That's roughly the size of a city. If Earth were compressed to the same density, our entire planet would shrink to about 300 meters across. You could fit the entire Earth inside Central Park. A single teaspoon of neutron star material would weigh about 6 billion tons, heavier than every building in New York City combined. Matter inside a neutron star is packed so tightly that atoms are crushed together, leaving almost no empty space. It's essentially a giant ball of nuclear matter. Now imagine you somehow reach the system and begin approaching in a spacecraft. You're still thousands of kilometers away. The first thing that would destroy you is radiation. Some neutron stars are pulsars, spinning rapidly and firing intense beams of X-rays and gamma rays from their magnetic poles. As the star rotates, these beams sweep through space like a lighthouse. But unlike a lighthouse, they carry enough energy to destroy everything in their path. Some neutron stars are a special type called magnetars. They have the strongest magnetic fields known anywhere in the universe, trillions of times stronger than Earth's. At a few thousand kilometers away from a magnetar, the magnetic field could begin disrupting atomic structures. Chemical bonds would break, your nervous system would stop functioning. But the real monster is gravity. The surface gravity of a neutron star is 200 billion times stronger than Earth's. To understand how extreme that is, imagine dropping a marshmallow from 1 meter above the surface. By the time it hits the ground, it would be traveling over 1 million kilometers per hour, faster than most spacecraft ever travel. Now imagine you're still 10,000 kilometers away inside your spacecraft. Gravity starts pulling on your ship, but it doesn't pull evenly. The side closest to the neutron star feels a stronger pull than the far side. This difference is called tidal force, and the closer you get, the less of your spacecraft remains. Then the same thing happens to you. Your feet feel a stronger pull than your head. The difference becomes so extreme that your body begins to stretch. Scientists call this spaghettification. You grow longer and thinner as gravity pulls harder and harder until there is nothing left of you at all, just a thin stream of atoms spiraling into the dark. Let's imagine the impossible. You somehow survive the radiation, the magnetic fields, and the tidal forces and reach the surface. The temperature is around 600,000 degrees Celsius. You vaporize instantly, but the surface itself is stranger than anything on Earth. The outer crust is made of atomic nuclei locked in a crystal lattice under immense pressure, possibly billions of times stronger than steel, the strongest solid material in the universe. Beneath that crust lies one of the strangest materials ever predicted by physics. Under extreme pressure, atomic nuclei form bizarre structures that scientists call nuclear pasta. Long strands called spaghetti, flat sheets called lasagna, clumps called gnocchi. These may be the strongest materials that can exist anywhere in the cosmos. Deeper still, the pressure becomes so extreme that neutrons may break down into their fundamental particles, quarks. This hypothetical state of matter is called quark matter. We've never observed it directly. Neutron star cores may be the only place in the universe where it exists. Every piece of gold on Earth was forged in a neutron star collision billions of years ago. When two neutron stars collide, the explosion is so violent it sends ripples through space-time itself, gravitational waves first detected in 2017. And in that collision, heavy elements are born. Gold, platinum, uranium, the ring on your finger began its existence in one of the most violent events the universe can produce.